Hello, in this section of the science of measurement and error analysis, this is the part 2. We are going to learn how to perform the error analysis in any experiment or measurement process. In the previous video, we talked about the error, concept of error or uncertainty, what we mean by it, what is error in scientific sense, what is error in the process of measurement or or performing any experiment, and why do we need this error analysis. So as discussed in the last video, in the last lecture, that error is the uncertainty or deviation from the actual values. The actual values that we expect from a measurement, there are some deviations. There can be several factors that cause a deviation from the exact values. Now, what we have to do, what is error analysis? If we try to define this term error analysis, error analysis consists of calculating these magnitudes of these deviations. Error analysis is the technique of measuring the amount of uncertainty or error in any experimental process. In any experimental process, we have to ascertain what is the magnitude or what is the value of this error, means how much our results are deviating from the actual results that is expected. So here we will learn some tools and techniques how to find the amount of uncertainty in an error in an experiment, and this is error analysis. So we will discuss about some tools of error analysis that we use in the process, in every experiment, in every discussion, in every kind of experimental or data analysis process. So let us first learn what are the types of errors, and then we can have an idea how to deal with these errors, how to deal with these quantities. So errors are classified in two major categories. One is the random error, another is the systematic error. So let us consider this random error first. There are different other types, there are different other terms that we will come in the later sections. What is this random error? The word used here is random. Random means something which is not going in a defined way, which does not have a well defined direction of propagation. There is no surety. The word random implies there is no surety. The word random itself implies that there is lack of surety, lack of confidence, or lack of exactness. Lack of exactness. We are not determined, we are not sure what we are in the report, what we are reporting. There is a lack of surety. So random means going something in a zigzag way, not defined direction. There is no defined definition of that process. So these are the errors or uncertainties that are defined in most of the textbooks as due to uncertainties that are random in nature. Random means they don't have any exact direction. And this random word is a very significant word in physics. The entire quantum mechanics, statistical mechanics, AC waves and oscillations, everything is based, everywhere there is this word random, fluctuation and deviation, everything is there. So let us learn about this random process or random error. This random word is this randomness or this random error. It is a deviation or spread from the actual value that occurs in both directions. Means if you are measuring something and you are getting a value, the uncertainty can be added to it as well as it can be subtracted from the value. That is why when we report these uncertainties, we report as x plus minus del x. X is the value of the quantity that you have measured. Delta x is the amount of uncertainty, and it can be added or can be subtracted. Means the best estimate, which is your x. X is the best value that you can expect, that you can report. This value may be added with something which is delta x, and it may be and that delta x may be subtracted from that value x. So this error delta x or uncertainty, it is in both directions. It is in both directions. So this delta x, it can be added as well as subtracted. So if this blue line in the diagrammatic representation, if we take this blue line is the exact value x, not exact value, the best estimate x. And our report of measurement, it can be x plus delta x or x minus delta x. So what we get, what is the result of our measurement? What is the result of our experiment? This is actually not this sharply pointed arrow, but rather it is something like this. It is in a range. This is a very familiar diagram in physics. We will come across this. This is our result. This is our result. The diagram is not very symmetric, but it is roughly dictating what we want to say. So the result of your measurement, the result of the measurement is distributed in a range. There is a range of values, x plus delta x, x minus delta x. It is not an exact value, as I have told you in the last lecture. Now, what is the method to measure this random error? What tools we require, and why do we require such tools? What is the reason behind choosing these tools? Let us first understand this. We have to measure this random error. We have to find out what these random quantities are doing. We will come to an example where we will see the random error examples. The first thing is that we have to understand is that the random error that occurs, that creeps into your measurement or experimentation process, is due to factors that are not necessarily in our control. We are not responsible for random errors. We are not exactly responsible for random errors. These errors or these uncertainties, they are inherently present in the measurement process. You cannot avoid them. You cannot avoid them. Neither I can avoid them, nor in any experimental can avoid them. For example, if you are doing the experiment of measuring the time period of a pendulum, you are counting the number of oscillations, and at the same time you are observing the stopwatch. There may be a delay, there may be a factor of reaction time in stopping and starting the stopwatch. Suppose you started the stopwatch and you did not start the oscillation at the same time. So there is a error that has crept into your measurement. You cannot avoid that. You have stopped the watch, but the oscillations are still going on. So again, there is a factor error, uncertainty. So these are some factors that they creep into your process, measurement process, without any control. There are many other examples. As these errors and uncertainties are random in nature, so what we need is a tool to analyze these errors. Which tool is suitable for measuring random quantities or random variations. And the best tool is provided by the statistical methods. statistics or statistical methods. We are well acquainted with statistics and statistical methods. From very school level, we are taught about that. Statistics comes into play when you have a large number of quantities. Statistics comes into play when you have a large number of population, when you have a large number of data points, when you have a large number of measurements, anything. When you have this a variety, a randomness, to analyze that situation, we use the statistical methods. Whenever there are large numbers of variables or large number of data points that need to be studied, there are large fluctuations, large randomness, and they are inherently associated with the quantities. For example, let us consider a very common example. For example, there is a class of 100 students. An exam is conducted with 100 students, and the full marks is 100. We have a class of 100 students and we have conducted an exam with 100 where the full marks is 100. Now, if someone asks, what is the performance of the class? What is the performance of the class? This is very difficult to describe with with the marks of individual students, because there are many types of students. Some are average students, some are below average, some are very good, some are extremely good. So the marks of one student cannot describe the overall performance of the class. So what we have to do? The marks obtained by a single student can range from 0 to 100. There are different types of students. There are students with different marks. And what you have a jingle of large numbers. Here you can see in the diagram. You have you have 100 values. Every student has obtained some marks, provided we assume that no student was absent and every student appeared in the exam. You have a jumble of numbers here, starting from 0 to 100. Now, how you can say what is the performance of the class? We cannot say it by the, if I get the copy of a student who has obtained 100 out of 100, I cannot say the class performance is 100%, because there is a student in the same class who has obtained 0 out of 100. How to deal with this situation? The performance of the class is obtained by a quantity called average marks. Same process is going here in the random fluctuation. Suppose you are doing an experiment, there can be many things. There can be many factors that are affecting your experiment. So if you are measuring something, you are measuring it just once. You are reporting that my result of my measurement is this much. As I discussed in the previous lecture, someone else comes in place of you, and again he or she measures that same quantity with the same instrument. He gets the different values, which is somewhat different from the value that you obtain. Now, how can you ascertain that what is the best estimate? We use this concept of averaging. We know this average quantity, average is equal to average. We know from very school level that whenever we are defining average, what we do, we have the sum of all the quantities. This is fraction, and you have this sum of the marks of students divided by the total number of students. Total number of students. This is how we define this average quantity, average marks. Now suppose in that exam, we continue with this example of exam. In the examination, the average marks came out to be 70 out of 100. Then what does this mean? Let us understand this. What does this average mean? What is the information that is conveyed by this average quantity? This means that 70 is the marks that is obtained by most of the students. This is clearly the meaning. Most of us are acquainted. We know this. What does this average means? We say average student. We say average income. Means this is the marks that is obtained most of the students. This 70 or near about 70. This can be said in other words. This is the marks in the words of probability, and this is very much applicable in statistical and quantum mechanics. This is the marks which is most probable. Again, it means the same thing. Most probable. This is the marks. This is the marks which is most expected. Probability, expectation value, expected. These are the terms that come in physics, quantum mechanics, statistical mechanics. And they are also dealing with similar situations where you have uncertainties and where you have randomness, where you have fluctuations. So this is the marks which is most expected. This is the marks. Again, we can say this is the marks which occurs maximum number of times. Maximum number of times. These three statements, or these four statements, they mean the same thing but in different ways. This is the last term is concerned with the frequency of distribution. So what we can say, the result report is the marks of the students, or we can say if you are considering the overall performance of the class is 70 out of 100. Now you can score it whether it is good, average, or very good, or not proper. That is a different thing. So overall performance is 70%. So maximum number of students have obtained 70 out of 100. So 70 is the value which is most expected, most common, most probable, most number of times occurring. Same thing, same, they mean the same. So this is the concept of average. There are of course students who have obtained 0 out of 100 and 100 out of 100. They are also there. But the overall thing is that the students have scored, their performance is 70%. Now let us use this concept in the case of random errors or in the experimental process. As I told you, that random error, they occur due to factors that are not in control, that are not in our control, and they creep in the measurement. So what you do, for example, I have taken here an example. that, for example, we are measuring the breadth of an object. It may be a square or a rectangle object. You are measuring the breadth of the object. You have measured it first time, first measurement. It gives you a value 31.33 centimeter. You have a meter scale. We will come to the least count concept later on. Then you are not sure that 31.33, it may be something different. There are some factors affecting my measurement. You take a second measurement and you get 31.15. Now you leave the measurement. You say that I am not able to get the exact measurement. My values are deviating. They are different every time I measure the object. Someone else comes and again he measures that with the same tape and he measures the same object, suppose, and he gets another reading 31.26. That person also repeats his process of measurement, and on the overall, in total, there are 5 measurements of the same object with the same instrument. Now, with this chart, what can you say? What is the value of the width? That we need to know. A set of 5 measurements have been taken. Now the question is, what is the width of the object? How can you say, if someone asks you what is the width of the object, you cannot say that I have taken 5 readings and these are the 5 readings. You have to tell him a single value. This is the process. In this situation, what we take? We take the average value. This average is a word which comes everywhere. The cartoon shows you have an average price. So when someone is saying average price, then that person is, of course, he means to say that the price has been ascertained by taking many factors into consideration, by taking many factors into account. So now what we need to do, we have to report our value, the result of the measurement. We have to take the average. Now, in order to report the value of the width, we have to take the average. We take the average of these numbers. We add 31.33, 31.15, 31.26, 31.02, 31.20, and you divide it by 5. So this is what we are getting. Average width. Let us calculate the average width. Width is, which is of course average. It is fraction, sum of all the values, 31.33 plus 31.15 plus 31.26 plus 31.02 plus 31.20, and you divide it by 5. So this is the average value. And suppose you get something. Suppose you get 31.25 centimeter, for example. So the width is reported as 31.25 centimeter, and this is the average value. Now, what is happening here? Let us try to understand this, and this is very interesting. When you are measuring the width for the first time, there are some random uncertainties that are coming into play, that are making your reading, that are making your result to deviate from the actual value. You do this, you perform the experiment, the measurement second time, same thing is happening. Third time also you are doing this, fourth, fifth, and you may take 10 readings, 12 readings, 15 readings, so on. So when we are doing this, when we are doing the average, we are actually dividing the random uncertainty factor into 5 values. We know the meaning of fraction from very school level. 10 by 5, 2. If we divide 10 objects among 5 people equally, each one is going to get 2. So when you are actually dividing, when you are doing this division of all the values by the total number of observations, you are dividing the uncertainties that are inherently coming in the experiment measurement process into 5 values. So what you are doing, you are actually minimizing the uncertainties. This averaging process is one process to minimize the random errors. If you measure now, suppose if you are getting this average value 31.25 centimeter, as I explained above, that this is the most expected value. It may not be the correct value. It is not the correct value at all. It is the most expected or most probable value of the width of the object. When you measure with very high, exceptionally high accurate instrument, this is the value you can most expect to get, 31.25. Other values that you have obtained during the experiment, they are deviating from this value, from this 31.25. Let me write suppose, otherwise someone will say that the averaging is wrong. So we are dividing this in this process. Let me write this first. In this process, we are dividing uncertainties that are inherently present in the measurement process into into 5 values. So this is a method to reduce the random uncertainty that is present in each process, in each step of measurement. So this is one, taking average is a method to reduce the you cannot totally omit the random uncertainties, they will be present. It is a method to reduce the uncertainty. The average value obtained is the most expected value of the width of the object. Now suppose you take 10 more values. Your total number of observations is 10. Now you are dividing all the 10 observations. You are summing over all the 10 observations and you are dividing by 10. You will get the average value. The more number of, how the number of observations affect the measurement process, we will come to this section. So this is the first tool of analyzing errors or uncertainties, the process of average, the process of taking average. This is a statistical tool. This means that the most expected that the most expected value of the width of the object, width of the object is 31.25 centimeter. This value is most expected or most likely to occur. Then again, there is another word. This value is most likely to occur. Though it cannot be said, it cannot be said to be the most exact value. This is the concept of average. This is the concept that we are in that we do. This is the thing that we are doing when we are measuring something, when we are taking the average of a quantity. This is the concept of average. This is the first tool to analyze errors. This is the first tool. This is the first tool to analyze the error or uncertainty in any experiment. So we can now say that in any experiment process, in any measurement process, what we report is not the exact value, but the most probable or most likely value of the measurement. Because there are random uncertainties present in the experiment, present in the measurement process that cannot be avoided. So what you report is the most expected, most likely, most frequent, most probable, or summing over all these words, summarizing all these words, you report the best estimate of the value, whether it is width of an object, length of an object, mass of an object, or anything. So in any experimental process, we report the most expected, most probable, most likely, or in a nutshell, the best estimate of the quantity. We cannot report the exact, most accurate and most determined, sure value of any object. What we report is the best estimate of a quantity. That this is the value which is expected, which is most expected, or which is most probable value. This is the best estimate that I can produce. This best estimate, still it has some variations, still it is deviated or spread away from the accurate exact value. And for that we need further tools. This best estimate is still spread away or deviating from the exact. So how to move further? How to further analyze the random errors? Because we are concentrating on this random errors because they are not in our control. They are not something that which we control, or it is due to the experimenter. They creep into your measurement process due to factors which you cannot control. You are measuring the time period of a pendulum, and suppose in a closed room, suppose someone opens the door very fast. The air column, the air disturbs your measurement. It disturbs the oscillations of the pendulum. So you are getting a wrong time period. These are the factors that affect these. You cannot control the air moving. Suppose you are taking the measurement and in course of measurement you sneeze. So you have missed some oscillations, you have missed some recordings of time. You cannot avoid that. So how to further analyze the random errors? We will move to the other types of tools in the next lecture. In the next lecture, we will see how to further furnish your results, how to further make them better free. You cannot make them free from random errors, how to minimize the random errors, how to report the uncertainties. And there are many things involved. There are many statistical tools, graphical tools that are associated, that are concerned, that we will study, that are very useful in studying these techniques. You can visit my site, learnandenjoyphysics.com. You can get there several articles related to concepts of physics, different branches of physics, notes, interesting topics. So please like, share, and subscribe. We will meet in the next lecture to further see the techniques of error analysis. Thank you.